Right, so some of you might see this and see a radical in here. And so the rules for radical are isolate your radical. So to do that, I'm going to add 11 root x to both sides. Okay, now, if I try to isolate completely and divide by 11, am I going to be left with a fraction? Yeah, so don't do that. It complicates things. Just leave it in the front here. And so you could square both sides. Now, you could also work to factor out a 3 here as well. Either way, it's fine. I'm going to leave it as like this for right now. Okay, and so here I expand my binomial square. I take my first term and square it, so 3 squared x squared. Next, I take the product of my terms and double it. 3x times 6 is 18x. Double that, we get 36x. And then my last term squared, 6 squared is 36. And then I'm going to square my 11 and my root x. So I've gotten rid of my radical in this way. And now, if this is the case, I have multiple variable terms in a quadratic form. So I'm going to move everything to one side and set it equal to 0. So if I subtract a 121x from both sides, I wind up with a negative 85x plus 36 is equal to 0. And now I see that this winds up being a relatively difficult problem to factor, right? If I try to rewrite my middle term, 9 times 36, that's not an easy number to manipulate. Okay, so what I'm going to do here is just look for trial and error. Okay, so I have 9x and x, or I have 3x and 3x. Again, there's a lot to choose from. If you wind up with trial and error, okay, by the time you get to this form, okay, our outer product is negative 81, our inner is negative 4, so that adds up to negative 85. You'd get your solution, in this particular case, setting each factor equal to 0. Take the opposite of your constant, divided by your coefficient, and then this one is equal to 9. So these would be your two possible solutions. Now, I did that easier than what it would take you because I didn't go through all the steps of trial and error. It's not an easy thing to do. You might have to test a whole bunch of different possible combinations. Okay, so let me show you the other alternate route to solving this. And I noticed that a number of you noticed it as well. Is the highest power double the smaller power, the other power? Yeah, a power of 1/2 and a power of 1. So this is of quadratic type. So what we can do is we can let u be the smaller of those square root of x. If that's the case, then what does u squared equal? X, right? So that allows me to replace the x with a u squared, the root x with a u. And now this winds up being a problem that might be easier to solve. If I test my leading coefficient, my constant, have a total product of 18. Are there two factors of positive 18 whose sum is negative 11? Negative 2 and negative 9. So if I rewrite my middle term in those forms, drop down my first and last terms, and then factor by grouping. Hey, what common factor can I remove from my first pair? U, leaving 3u minus 2. And from my second pair, 3, leaving 3u minus 2. My common binomial factor of 3u minus 2 comes out. My remaining factors of u and negative 3 form the terms of my other binomial factor. And then we can set each of these equal to 0. Again, u is equal to the opposite of my constant. So it's equal to the opposite of my constant divided by my coefficient. And then here, u is equal to 3. Okay, once I find what u is equal to, I then go back and I substitute back in my original value for u, which was root x. And I solve each of the resulting equations. So when I square both sides to undo that operation, I get 2 squared over 3 squared. And then here, when I square both sides, I get x is equal to 9. Now, the final step would be to check my solutions. When I test for the 9, I get 3 times 9 minus 11 times root 9 plus 6 is equal to 0. When I check this solution, I get 27 minus 33 plus 6 is equal to 0. Is 27 plus 6 equal to 33? Yeah, so they cancel, leaving 0. Okay, so 9 is going to work. Let's do the same test with 4/9. So I get 3 times 4/9 minus 11 times the square root of 4/9 plus 6. So when I look at this, the 3 goes into the 9 3 times. So I have 4/3 here, and then 6 is 18/3. So I'm going to combine those together. And then when I subtract 11 times this 2/3, 11 times 2/3 is 22/3, is 4/3 plus 18/3, also 22/3. Yep, so those equals 0, and that checks as well. And so both of those answers wind up working for this.